Okay, let's solve the following system of first order ODEs. And so our system is given here. So dx dt is 4x minus 3y, dy dt is 6x minus 7y. And so we have a system of two first order ODEs with two variables, x and y. So we have two initial conditions, one for x and one for y. Okay, and so let's go ahead and let's solve this numerically in MATLAB. So this is another case where the problem is not necessarily super interesting. A lot of these problems were taken from the textbooks in the Open Textbook Library, in which I could confirm that my analytic solution that I worked out myself was correct. Okay, and that way, while we're learning, we have something we can compare our answer to make sure that we solved it correctly. Okay, so I have a system of first order ODEs. Okay, and so our system's already set up, but the one thing you want to make sure you do is our first task is going to be to create a rate function. In order to solve this numerically, we need a rate function that tells us how x changes with respect to time and how y changes with respect to time. And so when it comes to massaging or manipulating your equations, what that means is we need to set them up in such a way so that I just have dx dt on the left-hand side and dy dt on the left-hand side, right? So if this were, say, 4 dx dt, then I need to divide through by 4, right? I need to make it so I just have dx dt and dy dt on the left. Okay, so I need to create a rate function. Okay, so I'll click New Script from Home. And so our rate function will take the form of function. Okay, so ODE 45 expects a rate function with a single output and two inputs. So we'll have our standard res over here. Okay, I'll call this rate fun. And this is in this version of the text example 10.2. And our rate function can have two input variables, t, and then our second argument will be v, value of our functions, in this case at t. Okay. So what I like to do first is I like to start by unpacking v. Okay, so v is a vector that contains the value of our functions at t. Okay, so we have two functions we're trying to solve for, two variables we're trying to solve for, x and y. So v will contain the value of x and y at a specific t. Okay, so you're free to choose the order of what you call, say, the first element and second, but once you choose it, you need to be consistent. So by unpacking, I remind myself and make it very clear what order I've chosen, and then it'll also allow us to write our rate functions in a form as more similar as they appear, in the problem statement. So by unpacking, I'll call my first element x. So I'll assign to x the first element of v, and I'll assign to y the second element of v. Okay, cool. So next, we want to compute rates. Okay, so I want to compute our rates. So dx dt, okay, so our first rate, and just to be clear, so once we unpack v, we're saying our first element of v is x, second is y. So when I calculate my rates, we're going to make sure that once we pack them up, our first rate is for the rate of change of x, second rate is for the rate of change of y. Okay. So dx dt is equal to 4 times x minus 3 times y. dy dt is equal to 6 times x minus 7 times y. Okay. And then last, MATLAB expects a single output variable, and so we need to pack up our rates then to return them. So we'll pack them up and assign them to res. Okay. So now when I pack them up, okay, so first element of res is going to be rate function for x, then comes rate function for y, order agreeing with the order in which I unpacked v up here. Okay. Then the other subtle but very important feature is when I pack them up, okay, I need to pack them up into a column, right? I need to pack them up into a column vector. So res needs to be a column vector. Okay. So this needs to be a semicolon so that this is row 1 and that's row 2 in this single column vector. Okay, cool. Okay, and I'll go ahead and save it as rate fun at 10.2. Okay, so one small note. So this came up in the last chapter too. You see MATLAB underlines t here. All right, and all that is that I have this input variable of t that isn't used at all within the function. So MATLAB is asking, are you sure you want to pass this variable to it? All right, and the answer is yes. Remember, ODE 45 expects a rate function with two input variables. In general, your rate can be dependent both on t and the value of my functions. And so I need to specify both of them. They both need to be there because ODE 45 is expecting to pass both of them. Okay, regardless of not if t is there. All right, and so you could always put a tilde in there for t as a MATLAB notation for having the space there for a variable, essentially by not using it. But I just always include t. That way our rate functions always look the same, and it doesn't cause any harm. Okay. So then to solve it, I'm going to solve and assign the results to variable. So I'll do t comma m is equal to, so our call is ODE 45. Okay. First argument is our rate function. So this will be rate fun 10.2. Second argument is the time over which I want to integrate. So I think this is 0 to 25. Then our last argument is going to be a vector containing our initial conditions. Okay. So in the last chapter it was just an initial condition. Now it's conditions. I need an initial condition for each function. Okay. And then so I'm going to pass my initial conditions as a vector. So when I pass my initial conditions as a vector, order again is important, right? And we just need to be consistent throughout the entire problem. So when I unpacked V, I said first element was X, second was Y. When I packed up my rates, first rate was rate of change of X, second was rate of change of Y. So when I list my initial conditions, first is initial condition for X, followed by my initial condition for Y. Bam. Okay. So rate function, time range, initial conditions, rate function has two inputs, t and value of my functions at that t. If you had some additional parameters you needed to pass, you would do that via an anonymous function. Okay, or you would just hard code them within that rate function. Okay, either or. Okay, but I solve. Okay, so t is a column vector containing the times at which my function was evaluated. So here, all right, and so I can even do size t here if I want to show it in the command window. Oh, I need to actually do size t. Okay, so size t is 197 by 197 rows in one column. All right, if I size m, okay, m has 197 rows in two columns. Okay, and so t is our column vector, contains all the times at which our functions were evaluated. M is a matrix where the first row is going to correspond to our first function x, second column corresponds to our second function y. Rows correspond to the values at corresponding elements of t in our time vector. Okay, and while not necessary, all right, so again, if I were to say plot t comma m, all right, MATLAB will interpret that as plot first column of m versus t, second column of m versus t. What I like to do is I like to split it up, right? So I like to split up so I remember. Okay, so x is first column of m. So I'll say all rows column 1. Y is equal to second column, so that's all rows column 2. Okay, let me see if I can shrink this so that when we plot, you can nicely see our windows. Okay, so let me clear that. So now if I were to plot, I can make it clear t comma x. I want to plot that as a black line. Then t comma y. Okay, and so when I list them sequentially like this, it's the same as if I'd used a separate plot command. Only listing them all in one command, you actually don't need the hold on. Okay, bam. So there's my plot. That's cool. And if I wanted to create phase plot and say figure 2, okay, I can plot. And let me drag it out so we can see it in action. Okay, so figure 2 here, figure 2 here. Okay, let's plot y versus x. Okay, we'll plot that. All right, so it's a straight line. So again, this isn't a very interesting problem. This is just a problem I took from one of the textbooks in the Open Textbook Library that I could solve analytically, and then they also provide an analytic solution so that I could confirm. Right, and in the problem statement, in the example problem, we check and compare to the analytic answer. Okay, so you could add labels, you could do all of that fun stuff, but that's that.